to learn REST APIs in ASP.NET Core, where do you even start? It's hard to get started without facing information overload. That's exactly why I created this beginner-friendly course, starting with what REST APIs even are and why we use them, then moving into .NET 9 to show you how to create APIs, handle all the main HTTP requests, connect your APIs to a SQL Server database so your data persists, and perform all the CRUD operations. Well, welcome to Code the Future. Alan here. My goal is to help you learn C# and .NET on your own, and let's dive right in. I'm gonna try to explain REST APIs in simple terms. Let's say you create a web app or a startup. You might eventually want to build a mobile app or another piece of software, or even allow other applications to access your app's data. To make this easy and efficient, you'll need a way for all these different app types to communicate with your app. This is where REST APIs come in. Most web apps use REST APIs to handle this communication. Instead of directly interacting with databases or business logic, the front end of all these apps sends requests to the REST API, which processes those requests and sends back the necessary data. To explain the term, REST stands for Representational State Transfer, which is just a fancy way of saying it's a set of rules for how systems can communicate over the web using HTTP methods like get, post, put, and delete. API then stands for Application Programming Interface, but you'll understand it much better once we put it into action. Now we're gonna create our very first REST API in ASP.NET Core in .NET 9. I'm gonna explain you how the project is structured, everything you need to know to get started, and pretty much how things work. So I have just opened Visual Studio here. Let me just create a new project and search here in the templates for Web API kind of project. The first one here, click on Next. I'll just name this like First API. Click on Next. I'm going to leave the version to be .NET 9. Every other configuration here, I'll leave them as they are and just create our project. Okay, our project is already created. Let's just see the main files that we have in our project solution here on the right. So we have program.cs, which is the entry point of our program. So here basically we are building the app. Here's the services container, then here is the HTTP request pipeline. We have all of this middleware. Here we're redirecting HTTP requests in HTTPS, which is the secure version. We're authorizing the requests that come to our application. We're mapping them to the right controller, and then we are running our application. We have then the app settings.json file, which is the main configuration file of our project. Here we have the configurations for logging. If we connect our project to a database, we store here those configurations as well. This is a place where we write the physical location of the database. Then let's just go to the properties. We should see the launch settings.json file. Here we have our application URL for the development environment, and let me just see what else we got here. This is a C# class, weather forecast class, which basically is the model for our REST API. This is how our data will be structured. So our REST API will contain data that have a date, a temperature, two temperatures, one in Celsius, one in Fahrenheit, and then a property for the summary of this temperature. And we should have also pre-built controller here, like a boilerplate controller. So if we go to our application's URL / the name of this controller, we should get the data that are generated in this controller. In this HTTP GET method, basically is just generating some weather forecast data for us, so that when we make a request to this specific endpoint, we will get the data that will be generated here. One big difference between this version and some of the previous versions is that our projects don't have Swagger anymore, which was this UI interface that we used to test our APIs. Instead, we see this file, this HTTP file that is generated now. If we write our endpoints here, we can test them directly from this file. We'll see another way as well in just a bit, but we should run the project first, and then we can test this first endpoint here, which is the endpoint specified in our controller that we just saw. Okay, we run the app. If I click on send request here in this window, should give us the response that we get if we make a request to this endpoint. And here we have this data that was all generated in the endpoint in this method right here. And this is one way we can test our endpoints. We're going to write them all here and can test them in this window. The second option that we have is actually let me just go to launch settings.json and take this URL that we have here, our application URL. If we go there, then, which was the endpoint, the name of our controller here, weather forecast, which we could also see here. This is how we test our endpoint as well. We even have the option here to check pretty print, so that we have them in one line, the data that we get if we make a request to this API that we had there. So there are also other options there. There's Postman, but these are the two ways that are already built in your project. If you want help building REST APIs or learning .NET in general, the easiest and fastest way, in my experience, is to get direct feedback and guidance tailored to you. That's why I created the .NET Squad community, where you'll get support directly from me and other .NET developers for any question or challenge you're currently facing. Surrounding yourself with people who share the same goals is also one of the best ways to grow as a developer. The best part, you can try it for free. You don't have to decide anything today, jump in for 1 week, explore everything, and then decide if you want to continue. The link is in the description. I highly recommend checking it out. Now let's get back to our video. Models represent the data of our application. Let's say that we want to create a REST API about users. The information that the REST API will contain then for each user is what we specify in a model. Model is basically a C# class, and if we were to store our data in a database, let's say, this model would represent a table in our database. Simple enough, hopefully. Let's see how this works. So I have just created an ASP.NET Core Web API project, haven't made any changes to the project here, and I'm just gonna go to the root directory and add a folder named models for our model. And here I'm going to add our model, which is the C# class. Okay, let's create a class for books, let's say. I don't think you guys read much books. It's not that I'm talking for myself or anything, obviously, but it's just an example. So I'm just gonna create a book.cs class. Okay, this is our class, and let's give it a few properties. If you just write prop and then hit tab, you just get this kind of template for our properties. The first one will be an ID property. Let's say we want for our books then to have a title. Since this is a string property, I'm just gonna give it like an initial null value to escape these warnings. And we would want to have like a property for the author of the book. That seems logical. And let's take like an other property as well. Let's say year published, for the year when the book was published. And this is our model with these 4 properties. What else is that we're gonna do in this video is that we're gonna create a controller, which is the place where we specify how we will interact with our REST API. Let's say how we will get the data from our API, how we will modify the data there or delete there. We specify all of this in our controller with different method types, which we'll see in another video. But for now, let's just create a controller. Okay, let's keep this simple. Just add a controller here. If you click on API, let's take an empty controller. Values controller, let's name this books controller. Okay, this is our controller. If you can see the route of the controller here on top, we can access this controller by just going to the root URL of our application, then /API/ the name of our controller, which is books. Actually, we'll see how this works later on. But now I'm not creating a database and storing data in there just so that we can test our API. But the simplest thing you can do is that you can create a list of data containing some data for the books. So I'm just gonna create a static private list of books. I'll name it like books, and I'm gonna explain everything why I'm declaring the list this way. New list of books. I'm going to need to import, I believe, the models directory on top of the page using models on top. So why are we making the list static? The reason for it is because this way the list will be created once when the controller is first instantiated, and then on each upcoming HTTP request that we make to our API, we would use the same list. So basically, if we add something to our list or we modify something, if we delete something, these changes will be saved for all the upcoming API requests. If we were to remove this static keyword, this list would be created each time we made a new HTTP request to our API, and we would lose every modification. Anytime we would add something to our API, these changes would be lost. In this case, that we wouldn't use the static keyword. Now, I'm just gonna go ahead and grab some book data on the internet, and I'll be right back. So here I just filled our list with some books. I just grabbed the data here on the internet. I haven't read any of these books, actually, not that you care. But this way we have some data that we can use to test our REST API. When building a REST API, understanding how each HTTP method works is essential for handling all the requests that come to your API. In this video, I'll walk you through every HTTP method, how they work, and how to implement them using .NET 9. We'll also make API calls inside our HTTP file for each method to test them and help you understand everything more clearly. So we have just created a web API project in ASP.NET Core. We have written a book model here, just a simple model, and a controller. All we've done in the controller is that we have only created a static list with some data for our books. And now in the controller, we will write all the HTTP methods to handle the requests that can come to our API. Users can make different kinds of requests to our API. They maybe want to get some data, modify some data, delete some, or submit data to it. And to handle all of these different kinds of requests that come to our API, we write our HTTP methods for each specific request type, and here we specify how these requests will be handled. So basically the response that we will give to the users. Our first method that we're going to create will be an HTTP GET method. HTTP GET methods are used when users send a request and want to retrieve data from our API. Here on top of the method, we write this HTTP GET attribute, and we will make the method to be public. This method will return an action result. We'll make a method to return a list of our books, but the reason we specify the return type to be action result here is that together with our data, the response will contain also a status code with the result of the request. So basically, if a user gets the data successfully, we return a 200 OK status code. Or if the request was not successful, we may return a 404 status code. And this result type is included in the action result. We will see different status codes in all of our methods, and we'll understand them better as we go. But for our first method here, as I said, we want to return a list of books. Let's name this get books. and we will return the books, which is the name of our list of books here, if you can see, but we will wrap this around an OK object. And what the OK object is, if you can hover over it, you can read here that this object creates the status code of 200 OK with the response. So basically, if a user requests to get the books in our API, it will receive the books and also this OK 200 status code. To test this, we can go simply to the HTTP file that we have here. And this is the root URL of our application. This is too long. I'm just gonna substitute this with like URL, or let's say root URL. I'll paste this here as well. And to separate different API calls that we do in our HTTP file, we need to just write these 3 hashtags, which just separates the different API calls that we make. And here we'll make a GET request to the root URL of our application, then /API/books, which was the endpoint for our controller. If you go on top of the controller here, this is the route of our controller. Let me go back here. And here we also can just specify, we need to specify the type of data that we are accepting, which is this application/JSON. Basically, we expect the data to be in the JSON format, which is this format that we get the data when we make a request to any API. We need to firstly run the program here. And then if we click on send request, okay, so we receive a 200 OK status code and we receive the list of all of our data in this JSON format. So these were all of the books that we had written in our list, and we are basically receiving this back as a response. Simple enough, hopefully. Now let's go back to our controller, and the second method that we're going to create is, it will be again an HTTP GET method, but in this case, we will write a method for when a user makes a request to our API and is requesting one specific resource or one specific book. This is what we'll handle here. So the method will be still an HTTP GET method, but since the user will be requesting a specific book, we need to specify the URL here in the HTTP GET attribute. We could actually specify it here in a route attribute, but the cleanest way, in my opinion, is if you just specify here on top that we are expecting an ID with this request. Just like that. The method will be again public. It will return action result. It will return a single book in this case. Let's name this get book by ID or something. And we're expecting as a parameter this ID with the request as well. Okay. The first thing we are going to need to do here is let's create a variable to get, let's name it book, to get the specific book with that specific ID from our list of books. So let's loop through our list with this first or default method. And what we are doing here is basically we're going to our books list that we have here, and we are searching for a book that has an ID equal to the ID that we are receiving here from this request. We need to make like a small check here. If the book is null, we will return a not found method. What this does is this, if you hover over this, is that the user will receive as a response this 404 not found status code, just meaning this resource wasn't found. But if the book is not null, what we want to do is we want to return an OK status code together with the book itself. We'll test this as well in the HTTP file we have here. Let me just run the application first. And then here, let's separate this API call with 3 hashtags. We'll make a GET request again to the root URL of our application /API/ books, then slash the ID of the book that we are requesting. Let's say book number 2. Let me specify here as well the type of data that we're expecting, which will be a JSON. If I click on send request here, we're making this API call. We receive the 200 OK status code as a response, and we're receiving the book with the ID of 2 that we were requesting. So we've learned so far how to get all the books and how to get a specific book. Awesome. So the third method that we're going to create in our controller will be a HTTP post method. When a user sends data to our API, for example, he submits a form and sends us some data, he needs to make an HTTP post request to our API. And to handle this kind of request, we need to create an HTTP post method. And this is what we'll do. We just need to specify on top here the type of the method, HTTP post, and the method will be public to return an action result, and it will return a single book for the book that the user will send to us. Let's name this method add book. In the parameter here, we are expecting a new book. So new book is the name of the variable. The type of data is a book. Okay, simple enough. We first need to check if the book that we are receiving is null. If that's the case, we can return a bad request response. What this method actually sends back is a status of 400, which basically means that this was a bad request, or that the data that was sent to us was not in a valid format. Now, if the book wasn't null, we can add the book to our list of books, just with this add method, and then as a return type, in the cases of post requests, as a return type in these kinds of methods, we need to return a response type that basically specifies that the resource was created or that the book was created. For this purpose, we use the created at action. The created at action result type actually sends back a 201 status code that basically means a resource was created. The parameters that this method receives is the name of the method, where this new resource can be accessed. So how we can access this new book that was created. Here we need to specify the ID of the new book. So ID equals new book.id. And this method will also return back the book that was created. So these are the parameters that this method receives. So this is how we manage a post request to our API. Now let's go and test this again. If I run the app here firstly, and then make a new API call, let's separate this with 3 hashtags. The API call will be a post request to the root URL of our application /API/books. We will accept as a response JSON data. And here we need to specify the new book that we want to send to this API. We need to write this in form of a JSON object. So you just need to open up the curly brackets here. Firstly, we need to specify the ID. So basically in this form that we were receiving the data before in a JSON format that you can see here on the right, let's make the ID to be 6. I think we have 5 objects. Let me actually test this again. Let's get all the books one more time. Okay. Yeah, we have books with IDs from 1 to 5. Okay, let's create this new book to have an ID of 6. Let's specify the title of the book. You know what? I'm just gonna write the name of the ebook I have written. So C# unlocked. The author is myself. And the year published was it last year? Yeah, I think it was last year. Okay, yeah, I think that's correct. So we can send this request to our REST API by just clicking the button here. Okay, so what I'm doing wrong here is that we're specifying here what type of data we're accepting, but actually we need to specify the type of data that we are sending with this API call. So we need to specify here as a header the content type to be application JSON. I've even written the title of my ebook wrong here. Okay, if we make the request now, we receive the 201 status code, which means that this resource was created, and we are receiving back this book data that we just added to our API. Okay, now if we try to get all of the books in our API, if we send this request to get all of the data, we should see that a 6th book was added in the end. Okay, so the next request type that we will handle for our REST API will be a put request. So when a user tries to update some data in our API, in this case, we need to create an HTTP put method. So let's go back to our controller here and specify the type of our method here to be HTTP put. So this is for updating data basically. The method will be a public method. It will actually be iActionResult and not ActionResult in this case, because here we're not returning any object. We're just returning status codes, and this is the most appropriate way to do it. Let's name this method to be updateBook. Here in the parameters, so I forgot, when an API call is made to update a resource, we need to also take the ID for the resource to be updated or for the book to be updated here. So let me specify the ID here in the route. Okay, and as a parameter for our method here, we are expecting an int ID and also a book object. Let's name this updated book. You can name this whatever. Okay, so first we just, as usual, we need to check if the book is null or not. And let me copy this from the method we had above. So basically we are looping through the list, finding the book, checking if the book is null or not. And if that's not the case, then we need to update all of the properties of the book with the properties of the new book that we receive in the request. So we need to write here book.id is equal to the updated book.id. Let's do this the same for the title and for the author and for the year published. Okay, at the end, if everything is successful, we need to return this noContent method, which returns a status code of 204, which means there was no content returned. That's how simple this method is. Okay, so let's just go ahead and test our API in the HTTP file. And if we go here, actually, because we run the application again, the changes that we made, this new book that we added to our list isn't saved anymore. So each time we run the app again or we close Visual Studio and open it up again, the changes aren't saved. For this reason, we're going to learn later on how to store our API data in a database. But for now, if we just go ahead and see the books that we have here, we should only receive the 5 original ones that we had. So that's what we are going to use to test our put requests. So let me just go ahead and write 3 hashtags here. The request type will be put request, which will go to the root URL of our application /API /books / let's say we want to change the book with the ID of 5. Here we need to specify the type of content, the content type of the data that we are sending, which will be of application /JSON. And let me copy what we had here, this JSON format data. So this will be for the item with the ID of 5. The title was Moby Dick. Let's leave the author to be myself and the year to be 1851. Okay, if we send the request, we should receive this 204 no content response type. And if we go ahead and get all of the books now, we should see that the author of the 5th book has changed. So now we're gonna go ahead and learn how to handle delete requests in our API. So let's go back to the controller. To handle delete requests, we're gonna need to specify the method type to be HTTP delete. So when a user or a client wants to delete some resources from our API, let's say like a book, in our case, we need to specify the ID to get the ID from the request. For this reason, we're going to specify the ID on top, and the method will be public, the result type will be iActionResult again. Because in this case as well, we are not returning any data, we are just returning a status code at the end. Let's name the method to be delete book. This will receive an int ID as a parameter. And what we're going to do first is we're going to go ahead and check in our list for the book with this specific ID. So I'm actually just going to go ahead and copy this. Again, what we had in the previous method. We're looking for the book with this ID. If the book is not found, we're returning the not found status code. And if we found the book, we're just going to need to remove it with the remove method from our books list, just like this. And then we are going to need to return a no content method again. Okay, let me just run the app here and go to the HTTP file. Let me just separate this API call with 3 hashtags. We'll make a delete request to our root URL /API/books/ let's remove the book with the ID of 4. Let me send the request here. Okay, we got a 204 no content response type, and if we go ahead and get all of the books, we should see that we have the 1st book, the 2nd, the 3rd. We do not have the 4th book, we only have the 5th book in this case. So congratulations, you learned how to handle the main request types in a REST API. Not storing data in a database is unacceptable for real-world applications, since the data will be lost as soon as we close our app. In this video, I'll show you how to connect your REST API in .NET 9 to a real SQL Server database so your data actually persists. We'll also go step by step to build out full CRUD operations to interact with our data using Entity Framework Core. So in this ASP.NET Core Web API project, up until this point, we have created a model, stored our data in a static list, and written all the HTTP methods to handle the incoming requests to our API. Now the next step would be to create a database for our project. I have already installed in my PC the SQL Server database and the SQL Server Management Studio. If you haven't though, you can just go to Google, search for SQL Server, and the first link here from Microsoft, if you click on it, you have the option to download it. You have the developer version and the express version. I'd say just go ahead and download the express version, since this is also for production ready apps. After you've downloaded it and installed it, it's pretty straightforward. Just go and search for SQL Server Management Studio, which is basically a tool that we use to help us manage our database. It should be one of the first links here, this one, in the Microsoft's website. If you just scroll a bit below, you have the option to download it right here, the latest version, and the download should start here on top. After you've downloaded this both, then just go back to your project and we're gonna create a database for our project here. If you go here on top to view, you can click on Server Explorer, and here on top where you read data connections, if you click with the right of the mouse, and you have the option here to create a new SQL Server database, which is what we're going to do. Okay, I'm gonna need to take the server name. Actually, I'll open SQL Server Management Studio here first. I'll take the server name from this. I'll just click on connect then, and I'll just go back to our project here, input the server name. Here you have the option where you read encrypt. Here I'm going to set it to false, which basically means we don't need a password to use when connecting to our database. I'm just going to click here as well to trust the server certificate. And here we can give a name to our database. Let's name this, the name of our project was here first API underline data. That's how I'm going to name it. If you click OK, the SQL Server database will be created. And here on the properties window, you should see the connection string, which you can copy. The connection string is basically the physical location of your database, so that our project knows where the database is located. Let me close this. Now, what we'll want to do is go to app-settings.json, where we need to specify the address of our database that we just copied. Here, you need to write connection strings, and we should give a name to our connection string. I usually name them like default connection or default connection string, something like that. And here I'm going to paste the connection string that I just copied. I'll save this here. In order to interact with our database, we're actually going to use Entity Framework Core. Entity Framework Core is a framework or tool that allows us to interact with our database using C# code. So basically any configuration that we want our database to have or our data that are stored there, we specify inside our project with C# code, and then we migrate them to our database. And Entity Framework Core is the tool that allows us to do this. One of the first steps we need to take is to create a context class. Context classes are part of Entity Framework Core that basically make the bridge between our C# code with our database. We're going to see how this looks like. Usually as a practice, we store this inside the data folder, this context class. So I'm just going to add a blank folder named data here. And inside of it, I'll add a class. And I'll give it a name like first API, which is the name of the project, context. Okay, this is our context class. We need to inherit here from the DB context class. Actually, firstly, we need to go to dependencies so that this class is known. We need to go to our dependencies, go to manage NuGet packages, and we need to normally install Entity Framework Core first. Okay, the first that we see here, click on install, click on accept. Okay, this was successful. If we go back to our context, now I think we just need to use Entity Framework Core on top of the page. And basically our context here is inheriting from the DB context class, which has a bunch of properties and methods that allow us to query data from our database or get data, do different kinds of operations to the data that we store in our database. Next, so that our context functions properly, we need to write a constructor here. And the constructor needs to take a few default configurations. So we'll give it this DB context options. We need to specify here the name of our context, first API context. We'll name this options as a practice. And this needs to inherit some base options. Okay, that was it for our constructor. Next, here, one more thing we need to specify in our context is that whenever we create a model, like we have here this book model, and we want to migrate this to our database, basically we want this model to be a table in our database to store our data, we need to specify a dbset instance inside our context. So if you write dbset here of type book, you usually name this a book in plural. And let's give it a getter and a setter. We need to, I think, yeah, we need to use the models on top of the page. When we migrate these changes to our database, this dbset instance will allow us to access this books table in our database and perform different operations to our data stored in it. We also need to do one last thing. We need to go to the program.cs class and we need to declare our context service here in the services container. So builder.services.add db context. Here we'll write the name of our context, which was first API context. And we need to specify some options here as well. Here in the options, we need to specify that we are using a SQL Server database. For this reason, we actually need to install the SQL Server database. Let me go back to the dependencies and manage NuCAD packages. If you click here, SQL Server, this Entity Framework Core SQL Server is the package that you need to install. Click on Accept. Okay, this was installed. Let me go back to our program.cs file. And here, after specifying that we are using SQL Server database, we need to also specify the location of this database, which was our connection string. To access our connection string, we need to just use here builder.configuration.get connection string. And here we need to specify the name of our connection string, which was the default connection, I believe. Let me close the parentheses here. And I believe on top of the page, we also need to write using Entity Framework Core. Now we are almost done. One last thing that we need to do now is to add the migrations to our database. A migration is basically a C# class that represents the schema of our database. So whatever data we are storing there, the relation between our data, like in our case, the model that we have created, this information is what a migration includes. And with the help of Entity Framework Core, this will then result in how our database will look like. In order to add these migrations, actually, we need to also add like a last NuGet package, which is the Entity Framework Core tools. This here, I think this is the last package we're going to need to install. So sorry about that. Okay, this is done. Let's now add the migrations to our database. You can just go to the tools tab here, NuGet Package Manager, and click on Package Manager Console. We need to write the command add migration. And here you can give a name to this migration, like an initial migration, or let's say book model added. So what we are adding to the database by adding this migration. Okay, the migration was added successfully. As you can see here, this is the migration class. You can see that here is specified that the table will be created in our database named books with all of these columns that we have specified in our model with an ID column, with a title, author, and the year published. Now for these changes to result in our database, we also need to write the update database command, hit on enter, and this table should be created in our database after this. Okay, if we can test this actually. If we go to the SQL Server Management Studio, go to databases and try to find our database, which was first API data, I believe that's how we named this. If you go to tables, okay, we have a books table here. If you click with the right here and click on edit top 200 rows, you should see a blank table because we haven't added any data to our table yet, but this is what we'll do right now. Now we could add some data manually in this table here, but we can do this as well inside our code, which is actually what I'm going to do in this tutorial. So let me go back to our context class. So what we're going to need to do is we're going to need to override a method from the base dbContext class. For this reason, I'm just writing here protected, override void on model creating. And this method will receive a model builder as a parameter. Next, we're also going to need to call the base implementation of the onModel creating method by just writing base.onModelCreating that takes the model builder as a parameter, so that the default configurations that this method has will still remain. And then underneath here, we will add data to our book table. We can do this by using the model builder parameter that we are taking with this method. This is a parameter from the model builder class, which actually we can use also to specify the different relationships of our entities, add data to them, just like we'll do in this case. So if we write here, if we specify here the entity, which was a book, and here we'll use the hasData method. And here I will add actually the books data that we had in our list. So if we go to the controller, I'm actually gonna take all of the books that we had in our static list, and I'm gonna store them in our database. Let me paste this here. Let's just indent this a bit. Okay, let's just close the semicolon here at the end. This, I don't think I've done any error here. So what we're gonna need to do is we're gonna need to add a second migration. So this data will be seeded to our database. So let's go to Package Manager console, click on Add Migration. Let's name this Book Data Added or something. Okay, this is our migration class. All of this data will be added to our books table. And if we just write the command update database, hit on enter. Okay, and this seems to be successful. If we go back to our SQL Server Management Studio and click here on Execute SQL. Okay, we have a table with 5 of our books with the data that we just migrated to our database. Now what we're going to do is we're going to access our database from inside our controller, so that with each REST API request that we receive in our application, we will access the database and the data will persist in our application. We will see how we can create, read, update and delete data from our database, so this CRUD operations. So let me just go to our controller here. And actually, I am going to comment this list that we have here out. And I will also comment out all of our methods that we have in the controller, since we are receiving a bunch of errors, and we will modify them one by one so that instead of accessing the list, we will access our database. So let me comment this out as well. I'll just leave the first method that we have here. So that we access our database, we'll use dependency injection so that we access our context. Firstly, I am going to need to have a variable here where we'll store our context. So this is what we'll use to access our context, this context variable, and we will also need to write the constructor for our controller here. And what we're doing basically is that we are setting the value of our context to this variable that we have here that we will use throughout our methods. So let's go to the first method, to our HTTP GET method. One main change that we'll do in all of our methods actually is that we will make our methods to be asynchronous, because each time we make an API call or we access the database, as in our case, we don't want the thread of our application to be blocked. If you know some apps, when you make something, you make a request and the UI stops, this is what asynchronous methods solve. So all we need to do is add an async keyword here before and wrap the result inside this task keyword, just like that. And here we won't return the books list, but we will need to await this method. We will access the context from this context variable .books, which was the name of the instance we declared in our context, .toList async. And what this does, this gets all of the books in our database. We'll test this in our HTTP file. Let me just run the application here. Let's go to our HTTP file. We already have some API calls written here. Let me get all of the data of our application. And this seems to work. We're receiving all of the data that we have stored in our database here. Now let's go back to the controller. Let me comment out the second method. Here, this will also be an asynchronous method. We need the async keyword there, and to wrap the return type in this task keyword. So I will remove this line here. The way we will access, we'll find a book. Here is by using the context. And actually we need to write the await keyword in front. So context.books.findAsync. We are using this asynchronous method. That's why we are writing the await keyword here in the beginning as well. And we are finding the book with this specific ID in the context. If the book is null, we return the not found. And then we return as a response the OK status code together with this book. That's all the changes we needed to do here. Let me run the app again and test our method. Let's go back to the HTTP file. We have an API call here that gets a specific book. Let's send a request here. Okay, we are getting the book with the ID of 2. So this works as well. Let me go back to the controller. Let me uncomment this post method. This will be an asynchronous method. Let's wrap this around the task keyword. What we'll do here is that we will add this new book to our database using the context.books.add the new book, and we will need to save these changes to the database. To do this, we need to use the save changes async method. So up until this point, we were reading data from the database. Now that we are performing an operation to the database, after we do this operation, we need to save these changes with this method. And that's it for this second method. Let me run the app, go to the HTTP file. We have a post API call here. The only change I'm gonna make here is that I'll remove the ID here because this will be generated automatically. And I think you'll receive also an error when you try to put the ID yourself in this case. So let me send the request. We received the 201 created status code. This was the book that we added to our database, and we can test this in our database. If we go to our database, click here on execute SQL. So we can see this data was stored in our database. My book here with an ID of 6. So this also proves that this is working. All of our data persists now in our application. Let's go to which is the next method. We'll need to uncomment here. Okay, this is the put method. This will be an asynchronous method. Okay, I will actually copy the code from here on how we find a specific book in our database. Let me paste it here. And I'll leave the rest as it is, other than after we change the data. We're gonna need to save the changes with the save changes async method. I'm gonna need to run the app. and go to our HTTP file here. Where was our put request? Let me get all of the data first to see what we have here. Okay, I'll change the last book that we added, C#. Let's just change the name here, C# ebook from me 2024. If we make this API request to our REST API, okay, we receive an error. This is my bad. We are making the request to the wrong ID here on top. The book's ID is 6. This is the issue. If we run this again, okay, we receive a 204 no content response type. If we check now to get all of our books, the 6th book here, the title was changed. We can go to our database and check here as well. Okay, the title of my book here was changed in the database as well. So this is all working. Now let's just go and change our last method, our delete method here. Let me uncomment this. This will be an asynchronous method. Let me get this line again. I'm just feeling lazy. Okay, we will remove the book here by accessing the context .books .remove. We as well need to save the changes since we are performing an operation to our data in our database, and that is it. If we run the app now, let's go to our HTTP file to test this. We have an API call here. Let's say we want to delete, let's leave it like that. We want to delete the book with the ID of 4. If I send the request, 204 no content response type. Let's go to the database, execute SQL. And as you can see, the book with the ID of 4 was deleted. We do not have it here anymore. Hopefully this was helpful. You can now build a REST API, make the data persist, connect the project to a database, and perform all of the CRUD operations. To build on what you learned in this video, the video on the screen is the right next step. So click on it. Thank you for watching, and I'll see you there.